Right. Alternatively to symmetric encryption, you've got asymmetric encryption. So this is the idea of, with symmetric encryption, the key distribution problem becomes quite a big issue, and it's especially big in uh, online life and online communication, online transactions, and because communicating that key is really important to the security of that communication. So what asymmetric encryption is the solution basically, and this is a method where each person has two keys, okay, and this means that different keys are used to encrypt than they are decrypt. So now you can look into the maths if you want to, but you honestly do not need to for computing at A level. But there are some really nice YouTube videos out there to explain the maths behind it. But unless you're a further maths student, I'd ask you to avoid it because it's just not worth it. It's not worth the pain. But you can get two keys that are mathematically related, but even given you might know one key, it is almost impossible to work out the other key. Okay, so just trust me that you can have two keys that can work in harmony together. They're mathematically related, but given you understand you know one doesn't mean you can know the second. Okay, so given that you can have two keys, we have a public key and a private key. So the public key, anybody can find out. So if you said you wanted to communicate with, somebody's email address, you can find out what their public key is. Their private key, however, is for them and them only, and that is never shared, and nobody else knows that. And that is completely private. Because it's never shared, it will stay private as well. So you've got a private key and a public key. So the way this is used, this system, is that if you've got a sender and a recipient, the sender has a private key and a public key. The recipient has a private key and a public key. They can find out each other's public keys, but they can't find out each other's private keys. But these two keys, remember, are mathematically related. So the sender's public and private are related to each other. The recipient's public and private are related to each other. So even if you look at somebody's public key, there's still billions of possible permutations that could be their private key. And as computer power grows, this is increasing. So the way that this works is I want to send something securely to the recipient. So what I would do is I would encrypt my email. Let's say it's an email. I would encrypt my email with the person I'm sending this to public key. Because the reason is, if I encrypt it with their public key, it's encrypted in a form nobody else can understand, so it turns into ciphertext. When they receive it at their end, the only person that can turn that ciphertext back is them, because the only key that's got that mathematical relationship to it is the recipient's private key. So I encrypt with the recipient's public key and will decrypt with the recipient's private key. It's the only they can decrypt that message, basically. And again, if they wanted to respond and send me an email back, they would encrypt the email with my public key, and then I could decrypt it with my private key. Now, these keys can be used for lots of other things like proving identity and things with digital signatures, which we're going to look at in a minute. But just understand, you need to understand, if you want to communicate with somebody, which key to use, and you need to understand that they're mathematically related, so that given it's been encrypted with one, the other key is used to decrypt, and vice versa.